Calculate the energy required to accelerate a 1 times 10 to the power of 8 kilogram spaceship to a speed such that in the Earth's frame of reference, a passenger inside ages only 10% as fast as we do on Earth. Compare this energy with the mass energy of the ship. When solving a problem about special relativity, it is always important to know what are some given conditions by the problem and the frame of reference we are talking about. From this problem, we know the mass of the ship, so M ship, is equal to 1 times 10 to a power of 8 kilogram. We also know that a passenger inside the ship ages only 10% as fast as we do on Earth. So the 10% here is telling us the time ratio of the ship frame of reference to the Earth frame of reference. So delta T ship over delta T Earth is equal to 10%, and 10% is equal to 0.1. We are asked to find the energy required to accelerate the ship so that it has a time ratio of 0.1. So how do we solve this problem? We can use time dilation to simplify this equation here. So according to time dilation, we know that the moving object frame of reference has a smaller value of time. So the clock in the moving frame of reference race slower. This tells us delta T moving is equal to delta T stationary multiplied by the square root of 1 minus v squared over c squared. And this does make sense because the square root here is always less than 1. And by multiplying delta T stationary by a quantity that's less than 1, we are reducing the clock's value to tell us how does the clock in the moving frame of reference rate. In this problem, the moving frame of reference, the frame that has a smaller rating value of time, is the ship frame of reference. So delta T ship is equal to delta T Earth multiplied by the square root of 1 minus v squared over c squared. And this is equal to delta T Earth multiplied by 1 over gamma factor. Right? Because we know gamma factor, so let me write this down. So we define gamma factor as 1 over the square root of 1 minus v squared over c squared. So this is the reciprocal of gamma, so 1 over gamma. So by using the relation here, we can simplify the equation here. So delta T ship over delta T Earth is equal to delta T Earth multiplied by the square root of 1 minus v squared over c squared and the whole thing over delta Te. This is equal to the square root of 1 minus v squared over c squared, which is equal to 1 over gamma and is equal to 0.1. And now we can solve for the gamma factor. So gamma is equal to 1 over 0.1, which is equal to 10. Right? So how does gamma connect to energy? Well, we know that the total relativistic energy is equal to gamma multiplied by the mass of an object multiplied by c squared. And this is equal to kinetic energy plus rest energy. In this problem, we know the mass of the ship, and we also know gamma factor, and we know c. The constant c is equal to 3 multiplied by 10 to the power of 8 meter per second. So we can calculate the total energy of the spaceship, which is equal to gamma factor multiplied by the mass of the spaceship multiplied by c squared is equal to 10 multiplied by the mass multiplied by c squared. And this is equal to kinetic energy plus rest energy. And rest energy is just equal to mass multiplied by c squared, right? So let me erase the equation here. So we know mass energy or rest energy is given by the mass, not the object. So even if we do not accelerate the spaceship, it still has a mass energy of mass multiplied by c squared. So the energy required from us is equal to the total energy when having a time ratio of 0.1 minus the energy it already have. So the total energy required from us is equal to E sub t, total energy, minus the object's own energy, the energy given by the object mass. And this is just equal to the kinetic energy, right? So it's equal to 10 the mass of the ship multiplied by c squared minus the mass of the ship multiplied by c squared. This is equal to 9 multiplied the mass multiplied by c squared. And mass is equal to 1 times 10 to the power of 8 kilogram. Speed of light is equal to 10 to the power of 8 multiplied by 3 and has a unit of meter per second. And this is equal to the square here. So multiplied by 9 multiplied by 10 to the power of 16. Sorry, here's 8. And this is equal to 81. So 9 times 9 is equal to 81 times 10 to the power of 16 plus 8 is equal to 24 kilogram meter square per second square. And this is equal to 8.1 times 10 to the power of 25 joule. Right. So this is the energy required from us.